All right. For today's Explore, what I want you to do first is to just give as many of these a try as you can. So try to do as many of these before I actually do them. Okay, and then you can go ahead and watch me explain. All right. So part A, t squared equals 400. Remember to undo a squared term, I must take the square root of both sides. Now, take the square root using your phone. You just have to make sure you turn it sideways like this, and you have to press 400 and then that square root sign. Okay, the square root sign on the phone. Also, make sure your landscape is unlocked. The square root sign is, oh buckets, it's over here. Let's see if I can find it with my finger. There it is. I don't know how many of us use your phone. It's right above the sign, or some people call it sin. Okay, so what I would do is I would type in 400 and then press square root, and you would get t to equal 20. But remember, when we're solving equations like this, we need to write plus or minus. I gotta have that plus or minus in there. Okay. Next one's very similar. All right, but before we can take the square root of both sides, I must divide by 4. So I get t squared equals 100, and then square root of both sides to get t equals plus or minus 10. All right. We're going to go opposite now. I have a square root. To get rid of the square root, I square both sides. So I'm going to square the square root and square the 9. These two things are inverse operations, so they take care of each other or cancel each other out. 9 squared is 81. Same idea, square both sides. Okay, now that 3y drops out, and I get 3y equals 81. Now I divide both sides by 3, so y equals 27. Okay, let's keep going. I got 1 over x equals 8. I can think about this when I see a rational equation like this, or a rational expression like this. You can do it two ways. All right. Some people like to clear their denominators, where they just multiply both sides by x. For some of us, it might make sense to just put 8 over 1 like that. So I have 1 over x equals 8 over 1, and then I can cross multiply and say that, okay, 1 equals 8x. Divide both sides by 8. X is 1 over 8. Same sort of idea with letter F. I can put the 8 over 1 and cross multiply. This time it's 1 equals 16x, because I'm doing 2x times 8. Divide both sides by 16. I get x equals 1/16. Like that. All right, so today our focus is on nonlinear equations. All right, solving nonlinear equations. How do you decide what to do first when solving an equation? And is a nonlinear equation necessarily more difficult to solve than a linear equation? Those are two things we should be thinking about today. Hopefully, the second one, you find that it's not always. Okay, it's not always. So there's, we've talked about quadratic equations. We're going to talk a little bit about those today. This is just a little, recap. Okay, remember quadratic equations are written in this form. This is called standard form, ax squared plus bx plus c. All right, or look something like that. Okay, even if you're given this, you want to set it equal to 0 in order to solve these quadratic equations. Are we going to have to use a quadratic formula in this particular section? No, we're not. But that's just a heads up. The quadratic formula will be coming in a later section in this unit. All right. I skipped the actual example, the actual question, but we begin by setting a variable. It said 8 blank 17. All right. So I want to actually set up using the Pythagorean theorem. Okay, it shows you a lot of work. Basically, what they're trying to get at here is this part. Okay, reviewing that when I see a squared term, I take the square root of both sides. Now, the reason we don't include plus or minus here is because we're talking about a triangle in this problem. Otherwise, we should we should include plus or minus, okay? If you're talking about a side length, you won't include plus or minus. You can't have a negative side length. But if I'm just looking for a solution, then I must include that plus or minus. So let's solve these equations. So this first one is similar to one we did in our Explore. All right, it's similar to this problem here. When we had our square root term, how did we get rid of the square root? Oh, I squared it. So if we look back here, I have a square root equation where it's the square root of x plus 8 equals 64. How do I get rid of the square root? I square both sides. Okay. Go for a second there. So now I got x plus 8, and 64 times 64 is 4,096. And I just subtract 8 from both sides. 4,088. And the biggest thing is that first step. Remembering the first step, to get rid of a square root, I square both sides. So this next quadratic here, I just have x squared. Just because I just have x squared, I can just solve it like you usually would. I just want to isolate my x term, excuse me. So I'll subtract 8 from both sides, and I get x squared equals 121. And then to get rid of this squared here, the opposite of a squared is square rooting. So x equals 11. But since we're just solving and not talking about a side length, I need that plus or minus. Remember, negative 11 times negative 11 is 121 as well. So I'm going to add another problem, and I want you to write that. You can write that on the same page as example 2, just kind of in the margin on the left there. You have a little bit of space there. Honestly, it's not going to take much space. I just want to make a point here. That this problem is probably about 2 or 3 steps, so it's not going to take very long. But let's focus on C for a second here. Okay, here's a cubic equation. So a cubic equation, I have this divided by 2 in the denominator here. All right, so I want to get rid of the divided by 2. I want to get rid of that 2 in the bottom in my denominator. To get rid of that 2, I have to multiply both sides by 2. Now, I said this before, and I'll say it again. I could just put that 62 over 1 and cross multiply. It's the same thing. All right, I might as well just do that instead. Okay, because, and if you wrote down that times 2, don't worry about it. You don't have to erase it. All right, if I do that, okay, we're kind of more used to cross multiplying. Well, 62 times 2 is just 124. So I get x cubed minus 1 equals 124. Add 1 to both sides. I get x cubed equals 125. Now, the question is, what do I do? How do I get rid of a cubed term? Well, similar to how I get rid of a squared term, I took the square root. To get rid of a cubed term, I'll take the cube root. And the cube root is a button either on your phone. All right, if I turn it sideways again, it's right next to the square root button. It's right above cosine or cos. Okay, if you see it, it's right there above the cosine. Okay, if I'm using a graphing calculator, all right, I'm just going to press math. It's math. I think it's math 3. Let me just double check that for you. Oh, it's close. It's math 4. All right, the fourth one down. In the graphing calculator, I can press the cube root first and then press 125. If you're using your phone, you got to press 125 and hit the cube root button, and you should get x. Now, the reason I don't put plus or minus is because it's a cube root. It's an odd index, okay? If this was a negative 125, this would be a negative answer. But if I multiply 5 3 times, all right, so I have to have a positive 5 because this answer is positive. Because if I did negative 5 times negative 5 times negative 5, that would be negative 125. If I do positive 5 times positive 5 times positive 5, that is positive 125. So here, when you have a odd index, what that means is this number here. I'm taking the cube root, if I'm taking the fifth root, if I'm taking the seventh root, this little number here is called our index. Okay, or if I have an odd power like x cubed, x to the fifth, x to the seventh, I won't have the plus or minus. Only on the evens do you include plus or minus. Okay. So again, I want you to write this in the margin next to example 2. All right, there's some space on the left there. So we'll call that D, and then it's the square root of x, and then make sure that plus 2 is on the outside. That's important. So there's a reason I'm doing this, or I'm doing this problem, okay? Because if you look at this here, notice how that plus 8 was underneath the square root. Well, in this problem, the plus 2 is outside of the square root. So normally, here, I just squared both sides right away. Well, I can't square both sides right away because the square root is not by itself. So I need to move the 2 over. So it's just the square root of x equals 10. And now since that square root is by itself, I can square both sides to get x equals 100. So it's important to understand that whenever we want to use these inverse operations, and what does that mean? Inverse operations mean if I have a square root, I square it. If I have a squared term, I square root it. Whatever cancels the operation out. Okay, in order to use those, I have to isolate our terms. I have to get the terms by themselves. Okay. What else? That's good enough. All right, so this is an example of a rational equation here. It says for the following equation gives t time need to travel 30 miles based on r speed. All right, so t equals, or excuse me, 300 over r. Find the rational, what speed was required to drive 4 hours. Then I went to this long explanation about how to solve the expression, but I don't necessarily, somehow they solve it is fine. But let's try, number 3. All right, so I got 64 over x plus 8 equals 1. I could do this 2 ways. I can multiply both sides by x plus 8, or I can just put 1 over 1 and then cross multiply. And I think we'd like the cross multiplication better. We're not even, I don't really need to ask. I know that makes more sense to some people. So this is technically 1 times x plus 8 on the left here, but that's the same thing as just x plus 8. Again, this is technically 1 times 64, which is just 64. And to solve this expression, I subtract 8 from both sides, and then x is just 56. Is there another one I could add? Sure. Let's add another one. Okay. We got a little bit of space. You can do this in the margin again. I'm going to add another one here. Last minute here. Let's just call this part B. 3b. All right. I'm going to do 3x over x plus 1 equals 8. Okay. So what I want you to do, actually, this is a good place to stop. So we can stop with this one, and then we'll do this one as a whole class. All right. So let's head back to class. We'll see you soon.